Hello, kulandirani kuphunzira lathu lero pamene tikupitiriza ndi coordinate geometry ndipo lero tipanga lesson 3 mmene tione parallel lines. Looking at the background, mbuyomu mwakhala mukuona the idea of parallel lines in many situations. Actually, when you were learning about properties of parallelograms, kudziwa kuti tikanena kuti ma parallel lines amapanga chani, lines that will never meet, lines that can never cross. It's what we describe as parallel lines. So yeah, you have done that in, I think, in junior secondary school, in junior mathematics. You have done that. Yeah, parallel lines never meet. And when you are using alternate angle, you are using a alternate angle, corresponding angle properties, those things. You also saw parallel lines. Okay, alternate angle, you saw Z angles, I think in material, corresponding angle, MATF angles. Those ones involved parallel lines. Yeah, so so today we'll look at the parallel line. Lines that will never meet. What makes them not to meet again? What makes them to continuously go like that without meeting, without crossing at any point? Yeah, so that's what we are going to do in this. It's a short lesson. Let us be together and enjoy. What makes lines parallel? Parallel lines must have the same gradient. That's what makes lines parallel. Malaini awiri ngati sakukumana, line yo ndi line yo maika chizindikiro ichi. Ngati sakukumana, it means they are parallel. Okay, so we are saying if they are parallel, it means they should have the same gradient. Phunziro lathu lapita tinaonekana kuti kodi tikati gradient ndi chani. Tikakamba za gradient timanena kuti is change in y, y2 minus y1, divided by change in x. Tinaonekana za zimenezi ukhoza kupita kwaona phunziro lathu la pambuyo, lesson 2, that is, you will find the nalongosola za gradient. So what it means, when you have this type of scenario, it means this change with change in y, which is change in y, change y, okay, and that change here, this one as well. There is also change in y there. So change in y. It also means this is change in x. Okay, change in x. The same scenario with that, change in x is that one. So it means as you change, as you go along, as you change, and if you go vertical as you change, the ratio for that has to be the same. That change has to be the same. It means ngati kupita kutsogoloko uko komanso kukwera mmwamba kasinthidwe kaje kakhale kofanana. That's what it means. So kasinthidwe kaje kakhale kofanana, it means these lines will never meet. Okay, so that's what makes lines to be parallel. Gradient always the same. So kuyambira lero you have to know that lines, for them to be parallel, it means that they have the same gradient. So we are going to make use of that to do a number of stuff. Let's look at an example. In this example, they're saying show that the line passing through 1,3 and 2,7, those are points, is parallel to the line passing through 4, 3 and 3 minus 1. Okay, so let us visualize them by putting up a Cartesian plane. So trendy Cartesian plane here. So they're saying show that line passing through point 1, 3. Let's look at 1, 3. That's 1, 3. It means okay, it's that point 1, 3 and 2, 7, 2, 7, 2. Oh, okay, let's add there. Let's do this. Let's recalculate this. You can say that's 1, 2, 3, 4, 5, 6, 7. Okay, so they're saying 1, 3. So that's 1. That's point number 1, and 2, 7. That's 2. Y7. So go up to there to where the 7 is there. So it means this is our line. Okay, this is just a sketch. That is our line. Line 1, that's line 1. And line 2 is where they're saying it's 4, 3. So that's 4, 3. That's 3. It's here they're meeting. That's another point. And 3, minus 1. Okay, so that's 3. Point minus 1 is here. So it means, yeah, sorry, they're meeting here. So that's point 3 minus 1. Okay, so let's draw that line as well. Okay, yeah. So that's saying we have line 1, that one line, and the line 2. So they want us to show that these lines are parallel. Okay, how do we show that? It's simple. We have to make sure that the gradient of line 1 and the gradient of line 2 are the same. Okay. Okay, so remember we said that this line point is 1, 3, this point, and this point is 2, 7, and this point is 4, 3, and this point is 3, minus 1. Okay, as given there. Then let us find gradient of the first line. Gradient for line 1. To know this change in y divided by change in x. So change in y, which one is your y? 3 and 7, those are your y's. Okay, there's 7 here and there's 3 here. So for you to find change in y, it means it's 7 minus 3. Okay, for the first line. Okay, so change in y in this case will be 7 minus 3 divided by change in x. In change in x, it means it's from that point that's one. Change in x, it means we have 2 and 1. Okay, 2 and 1. It means there is this 2 and that 1. So it's 2 minus 1. So that's the change that we have. Okay, from 1 to 2, what is the change? It means it's 2 minus 1. So you have 2 minus 1. Okay, so it's 2 minus 1. All right, so this one will give you the gradient as there it's 4 divided by 1, which is equal to 4, which means the gradient for line number 1 is 4. All right, so let's look at the gradient for line number 2. Gradient for line number 2. Okay, which one is your y? Your y is 3 and minus 1. So you do the same. Change in y will be 3 minus 1. Okay, minus negative 1, that is. Okay, so it will be change in y, which is 3 minus negative 1. Okay, divided by change in x, and change in x is 4 and 3. So it's between 4 and 3. So the change there is 4 minus 3, which will be equal to 3 minus 1 will be equal to 3. The sum to 3 plus 1 over 4 minus 3. 4 minus 3, that's 1. So this one is equal to 4 over 1, which is equal to 4. So since the gradients are the same, here we have 4 and there we have 4, we can conclude that therefore the lines are parallel. Reason, same gradient. Okay, same gradient. That's the first example. Let's go on. And we have this other scenario where we are saying find the equation of a line. Okay, you see, this is how you can also use this this technique of parallelize. You can find the line of a certain point if you have another line. Okay, so find the equation of a line through point this, which is parallel to the line that one. Okay, remember we have a form a straight line is usually given by y is equal to mx plus c, where m is the gradient and c is the constant. Go revise lesson yatuyabira, you will understand this. So akunena kuti line e, okay, we should find another equation of a line imene kudutsa pa point A, and they should be parallel. Right, so the first thing is to put things straight. Okay, we are given 2x minus 3y, which is equal to 4. The first thing is to put this equation into a form like that one, to be in that form. Okay, so for us to do that, it's simple. Okay, it means we're going to say okay, we may say, okay, they'll do a bit of it. So we have 2x, 4 will be minus 4 will be equal to 3y. Okay, so let us rewrite it. Yes, so say 3y is equal to 2x minus 4, which means y, okay, y will be equal to 2. We'll divide both sides by 3, so it will be 2 over 3x minus 4 over 3. Okay, I hope we are together here. So having this, we know that from that standard equation, we know that this 2, it means our m is equal to 2 over 3, and yeah, that is our c, using that, is equal to minus 4 over 3. Okay, so remember, lines are always parallel if they have the same gradient. Remember, m is gradient if they have the same gradient. So what we want from this, we have that point. Okay, so we need to have an equation, okay, which is passing through that point. So that equation could be mx plus c. Okay, we can take this out, we don't need it. Okay, in this case we want to prove that for this second equation that we want to find, which is passing through 1 and 2, to be parallel to this equation. Okay, so we have the gradient. If this one has the same gradient as this one, it means these ones are parallel. Okay, therefore, if we substitute there, for us to have the same gradient as that one, it means we need to have m the same as that one. So it will be 2 over 3x plus c. Okay, but you are given the point there. So you have like y is equal to 2 over 3x plus c. Here you have one unknown. Okay, that is okay. You have one unknown c, because y and x we have those points. Okay, it means on y, because this line has to pass through there, it means that is y, that is x. It means for us to find c, we need to substitute those points into our equation to be 2, that's y, and 2 over 3 multiplied by x is 1 plus c. Okay, so for us to find c, it means that c will be equal to 2 times 1 divided by 3 is 2 over 3. So it will be c will be equal to 2 minus 2 over 3. We are capital. Okay, so let's go pambali. 2 minus 2 over 3. That's over 2. So common denominator is that one. So 1 into 3, 3. So that will be 6. 3 times 2, that's 6, 3, 1. So that will be 4 over 3. Okay, 4 over 3. 2 minus 2 third. Okay, yeah, so it means that your equation, so we now know c. We now know c. It means your second equation, therefore your second equation will be y is equal to m, we know, is 2 over 3 x plus our c we have found is 4 over 3. Okay, it's as simple as that. It's as simple as that. Yeah, so basically that's that. Maybe just a recap of the last example. You have the equation, which is you're given equation 2x minus 3y is equal to 4. Now this equation should be parallel to equation which is a line, because this is a line, to a line which is passing through point 1 comma 2. Okay, should be parallel to that point. So writing this equation into a normal form, so you have is a 2 over 3 x plus 4 over 3. No. Yeah, so this should be minus here. Minus 4. Because this one, when that goes that side, yeah, like that. That's how we found. Okay, so having this, we have the gradient m as 2 over 3. So For us to find a line which is passing through there, that line has to be parallel to this line, which means it has to have the same gradient. So it means y is equal to m x plus c. That is standard. It means y will be equal to, we substitute the gradient there, 2 over 3 x plus c. Okay, so you look at that, you are given the point. You can pick any point as long as it is passing there. So in this case it's passing 1, 2. So from there you know that that's your y, that's your x. So you substitute here, where there's y you put it 2 over 3, where there's x you put 1 plus c. Okay, so the same to say now, c will be equal to 2 minus 2 over 3. So if you do that, 3 common denominator, so there is 6, so 1 minus 2, so that is a good in the 4 over 3. That's our c. Therefore the complete equation, which will be parallel to that equation, will be equal to 2 over 3 x plus 4 over 3. As simple as that. Yeah, reaching this far is also the end of our lesson. See you in the next lesson. Thank you.